In 2017, a Japanese railway company issued a formal public apology to the entire nation. Their mistake? A train departed just 20 seconds earlier than scheduled. Welcome to Japan, a country where a delay of 30 seconds can be considered unacceptable, where bullet trains race across the country at speeds of over 320 kilometers per hour, and where more than 10 billion passengers have traveled on the Shinkansen network without a passenger fatality caused by a collision or derailment. Even more astonishing, this entire railway system operates in one of the world's most earthquake-prone countries. So how did one island nation turn rail travel into one of the greatest engineering achievements in modern history? Before going any further, there's one word you'll hear throughout this story: Shinkansen. Outside Japan, it's known as the bullet train because of its sleek, bullet-shaped nose. But in Japan, it's called Shinkansen, which literally means new main line. It isn't just a fast train, it's a completely separate high-speed railway network built exclusively for passenger trains. The story began after World War II. Japan's economy was recovering at an extraordinary pace. Factories expanded, cities grew rapidly, and millions of people traveled between Tokyo, Nagoya, Kyoto, and Osaka every year. The existing railway network, built for slower trains, could no longer keep up with the country's growing demand. Instead of upgrading old tracks, Japanese engineers proposed something the world had never attempted before: a dedicated railway designed exclusively for high-speed travel. In 1964, just days before the Tokyo Olympics, Japan introduced the world's first high-speed railway, the Tokaido Shinkansen. Connecting Tokyo and Osaka, it transformed a journey that once took several hours into a fast, reliable service and changed rail transportation forever. It wasn't just the birth of a new train, it was the beginning of a new way of moving an entire nation. Keeping trains on time has become one of Japan's greatest achievements. On many Shinkansen services, delays are measured in seconds, not minutes. In 2017, a Japanese railway company issued a public apology after one of its trains departed just 20 seconds early, because passengers expected it to leave exactly on schedule. That level of precision depends on more than technology. Train drivers follow a safety practice called pointing and calling, physically pointing at signals and speed indicators while saying each check aloud. The method helps reduce human error and keeps operations consistent throughout the network. Even when delays are unavoidable, railway companies issue official delay certificates, allowing passengers to explain their late arrival at work or school. In Japan, punctuality isn't just expected, it's treated as a responsibility. Japan experiences thousands of earthquakes every year, making it one of the most seismically active countries in the world. Yet its high-speed trains continue to operate with an extraordinary safety record. So how is that possible? The answer lies beneath the tracks. Hundreds of earthquake monitoring sensors are installed across the country. When they detect the first seismic waves, they instantly send emergency signals through the railway network. Power to affected sections is automatically cut, and trains begin braking before the strongest shaking reaches them. Safety doesn't end there. Railway tracks, bridges, tunnels, and overhead power lines are inspected regularly, while advanced monitoring systems watch for even the smallest signs of damage. These layers of protection allow the railway network to respond within seconds when nature strikes. The result is remarkable. Since the Shinkansen began operating in 1964, it has carried more than 10 billion passengers without a passenger fatality caused by a train collision or derailment. In a country where earthquakes are a part of everyday life, Japan didn't just build faster trains, it built one of the safest railway systems ever created. Building a train that moves at 320 kilometers per hour isn't just about adding a more powerful engine. It's about solving engineering problems that no railway had ever faced before. Take the iconic long nose of the train. It isn't there for appearance. When the early Shinkansen entered tunnels at high speed, they pushed a massive wall of compressed air ahead of them. As the train burst out of the tunnel, it created a powerful pressure wave, known as a tunnel boom, loud enough to rattle nearby homes. To solve this, engineer Eiji Nakatsu, who was also a bird watcher, looked to nature. He noticed how the kingfisher dives from air into water with barely a splash. By redesigning the train's nose to mimic the bird's beak, engineers dramatically reduced tunnel boom, cut power consumption by about 15%, and allowed the train to travel even faster. The railway beneath the train was redesigned just as carefully. Instead of short rail sections joined together, engineers welded the steel rails into long, continuous tracks, creating a smoother ride and reducing wear at high speeds. Instead of traditional gravel ballast, much of the Shinkansen network uses reinforced concrete slab tracks. They provide a stronger, more stable foundation, reduce vibrations, and require far less maintenance over time. Safety was engineered into the infrastructure as well. Shinkansen lines have virtually no level crossings, meaning roads, vehicles, and pedestrians never cross the tracks at the same level. The trains are also protected by automatic train control, which continuously monitors speed and can automatically apply the brakes whenever necessary, adding an extra layer of protection beyond the driver. But Japanese engineers weren't satisfied. Their next breakthrough would remove the one thing almost every train on Earth still depended on: its wheels. That breakthrough was the SC maglev, short for superconducting magnetic levitation. Unlike traditional trains, it doesn't roll on steel rails once it reaches top speed. Instead, supercooled magnets lift the entire train 10 centimeters into the air. It literally floats. Making a multi-ton train float safely comes down to three forces: propulsion, levitation, and guidance. Coils embedded along the track walls pull the train forward, lift it into the air, and lock it perfectly in the center. At low speeds, it rolls on retractable rubber wheels. But as it accelerates, the magnetic force takes over, pulling the wheels up and letting the train glide pure on air. In 2015, the SC maglev shattered world records by hitting an unbelievable 603 kilometers per hour. The first commercial line, the Chuo Shinkansen, is already under construction. It will link Tokyo to Nagoya before stretching all the way to Osaka. Once complete, the journey between Tokyo and Osaka will drop from nearly 2.5 hours down to just 67 minutes. To put that in perspective, you could travel across an entire country in less time than it takes to watch a single movie or sit through a football match. 60 years ago, Japan changed the world with the bullet train. Today, they are redefining travel all over again by building a train that flies without ever leaving the ground. Japan's railway companies don't just sell tickets. They own the entire ecosystem. Operators build department stores, hotels, and apartments directly over their stations. By turning train stops into living hubs, every neighborhood feeds passengers to the train, and every train feeds customers to the shops. Japan's obsession with perfection extends to every detail of daily operations. Take the famous 7-minute miracle at Tokyo Station. Specially trained cleaning crews have just 420 seconds to scrub an entire Shinkansen, sanitize the cabins, and mechanically flip every seat to face forward before the next departure. So, if a country can build a train that arrives within seconds, survives earthquakes, and even floats above the tracks, what else becomes possible? Because there are wonders hidden everywhere. And every wonder has a story. This is Wonder Doc Studio.